Okay, so like we said the other day, okay, our first step in being able to predict the products of a reaction is to identify the type of reaction that's going on. So in question number 1, I have sodium chloride reacting with calcium oxide. Those are both ionic compounds, so this is what kind of a reaction? Double replacement. Okay, in a double replacement reaction, what am I supposed to do?
Replace the ionic metals.
Right, just swap the metals, okay? That's all that's going on in this reaction, okay? So on the other side of this, I'm gonna have sodium with oxygen and calcium with chlorine, right? So now I've decided who goes with who. Now I have to look at the fact that these are both ionic compounds and need to be balanced, swapped and dropped, okay? So I get the right numbers. All right, so I'm looking at sodium, which is a +1, oxygen, which is a -2, so this will be Na2O, right? And then I've got calcium, which is a 2+, with chlorine, which is a 1-, so we're going to be looking at CaCl2, right? And then my last step is to do what with the whole reaction? Balance the reaction. Okay, so now I need to look at sodium is a 2, so I'm going to go over here and make sodium a 2. That makes chlorine a 2. It's a 2 over here on the product side. There's 1 chlorine and 1 oxygen on both sides. That reaction is now done. Okay, questions on number 1. Now, question number 2, I have an ionic compound, iron 3 bromide, reacting with an element, sulfur. Okay, so what kind of reaction type starts with an ionic compound reacting with an element? Single replacement. Okay, in a single replacement reaction, the pattern is that the element will replace the part of the ionic compound that it matches. Okay, sulfur is a non-metal, so it's going to replace bromine, which is the non-metal in the ionic compound. So what that means is iron's new partner will be sulfur, and bromine will now be alone. Okay, and we said yesterday, single replacement reactions are one of the ones where we have to be most mindful of special elements and the fact that we are going to have an ionic compound that will need to be dropped and swapped. Okay, so first off, is this a special element? Yes, it is. Okay, bromine always comes as a 2, so I'm going to put that there. All right, then I've got to drop and swap my ionic compound. Now, iron has more than one possible charge. It can be a 2 or a 3. So I need to go back over to this side and figure out what it is. Okay, bromine's a -1, and there's 3 of them, so this must be the iron that is the 3+ charge. So 3+, sulfur's a -2, I'm going to have Fe2S3. All right, looking like we're going to have some big numbers here. I need to now balance my whole reaction. What should I balance first? Sulfur, biggest number. Okay, there's 8 sulfur over here, and on this side there are 3. What's the number that both 8 and 3 go into? 24. Okay, that's the lowest common multiple of those two numbers. Okay, so what I'm going to do is make sure that I have 24 sulfurs over here by simply multiplying by 8. Okay, when I do that, I need to go back over here and make sure I have 24 sulfurs by multiplying this by 3. When I put this 8 here, it gives me how many iron? 16. So I've got to go back over here and make sure I have 16 iron. Now, like I said, we're getting some big numbers here. Okay, when I put that 16 here, that's 16 times 3 bromines. That's 48. Okay, so there's 48 bromines. That means I need to have a 24 over here. Okay, sometimes that happens with sulfur because it's got such a big number on it. Sometimes we get really big coefficients, really big balancing numbers, okay, to deal with. And that is the lowest form. Okay, I can't make those numbers any smaller. All right, how many people are done number 3? Okay, let's have a look at that one too. All right, so number 3, I've got C8H18 reacting with oxygen. What kind of reaction is that? It's a combustion reaction. Okay, the products of a combustion reaction are always carbon dioxide and water. Okay. Now I need to balance. Do I need to use both balancing rules for this one? Is 8 an even number? This is yes. This is no. Okay, yes. It is an even number. All right, so I need to start with a 2. All right, 2 times 8 is 16, so I'm going to put a 16 right here. Okay, 2 times 18 is 36. right? So I'm going to need to put 18 over here to get 36 hydrogens. And then I need to look at my oxygens. So I've got 32 oxygens here in the carbon dioxide, plus another 18 for a total of 50. Okay? So I need to put a 25 here to get 50 oxygens. Okay, questions on number 3? All right, how many people have done number 4? Okay, I'm going to give you guys a couple more minutes and then I'm going to go over 4 and 5. So for number 4, I've got beryllium reacting with fluorine. Okay, so element reacting with element. Only reaction type that has 2 elements for reactants? Synthesis. Okay, so in a synthesis reaction, okay, we simply put them together in a compound. Beryllium's a metal, fluorine's a non-metal, so this is an ionic compound. I need to make sure I put the metal first and the non-metal second, right, so that I make a true ionic compound. Since I've made an ionic compound, the next thing I need to do is drop and swap. This is a -1, beryllium is a +2, okay, so we're looking at BeF2, okay, for our formula there, and that means that the equation is already balanced. All right, then the last one. We only have one reaction type that starts out with only one reactant, and it is decomposition. All right, so in a decomposition reaction, we simply break the atoms apart, okay, into their elements. So we got chromium and we've got nitrogen. Decomposition reactions are another reaction type where we have to be on the lookout for what? Yeah, special elements, okay, ones that come as 1s or 2s, or sorry, as 2s or 4s or whatever. Okay, chromium's a metal, so I don't have to worry about that. Okay, but nitrogen is a special element and always comes as a 2. Okay, so now I need to go back and balance the whole reaction. Okay, nitrogen's out of balance, so I need to put a 2 here. When I do that, it makes 2 chromium, so I need to put a 2 there in front of chromium. Okay, all right. I'm going to number you guys off. Okay, I want you to go to the board, okay, of the number I give you. So for question number 1, or sorry, for question number 6, we have a double replacement reaction, okay, because those are both ionic compounds. So all we're going to do is swap the metals. That means that barium is going to end up with sulfate, okay, and copper is going to end up with phosphate. All right, since they're both ionic compounds, they both need to be dropped and swapped. Barium's a +2, okay, and sulfate is a -2, so that compound is fine the way it's written. Okay, copper can be a 1 or a 2, but I can tell from this side that it must be a +2. Okay, so I'm going to go back over here. This is a +2, this is a -3, okay, so I'm going to drop and swap. 1 mark if they've got those products. Okay, barium sulfate BaSO4 plus Ca3PO4 in brackets 2. Okay, then we have to balance this whole thing. Okay, I'm going to start with barium. It's a 3 over here. I'm going to make it a 3 over here. Okay, that is going to give me 3 sulfates. So I'm going to put a 3 here to balance my sulfates. That gives me 3 copper. I have 3 copper over here. 2 phosphates, 2 phosphates. Everything's balanced. So 1 mark if they have 1, 3, 3, 1 for their balancing. Okay, question number 7. Only one reactant, so it's a decomposition reaction. All we're going to do is split up the 2 elements, lithium and nitrogen. Either one of them special? Nitrogen. Okay, so 1 mark if they've got Li plus N2. Then we got to go back and balance everything. I'm going to start with the nitrogen because I can see that if I balance the lithium, I'm going to have to start over. So I'm going to put a 2 there. Okay, that's going to give me 6 lithium. Put a 6 there, and now my reaction is balanced. 2, 6, 1. Any questions on that one? All right. Question number 8. We've got a combustion reaction, so the products will be CO2 and water. Okay, and we don't need the rule of 2 because 9 is an odd number, so I'm just going to balance with that. Okay, 9 there. I need 20 hydrogens. I've got 10 oxygens here in the water plus another 18 in the carbon dioxide for 28. 14 times 2 is 28. So our number should be 1, 14, 9, and 10. Okay, so 1 mark for CO2 and water and 1 mark for it being balanced correctly. Okay, number 9, I've got nickel reacting with phosphorus. 2 elements are reacting. Okay, so this is going to be a synthesis reaction that is going to produce an ionic compound. Right? Now, here's the trick with nickel. It has more than one possible charge. Which one do I pick? The first one. Whichever one is listed first is the most common charge. Okay, if I have no other way to figure it out, that's what I have to do. Okay, so I have to figure it out that way. Okay, and just put it in here. So nickel's most common charge is 2, right? Okay, so this is a 2 plus. Okay, this is a minus 3. Okay, so I'm going to have Ni3P2. All right, questions on that one? Sorry, we got to balance it first here. So we've got 3 nickel. Sorry, we got to balance our phosphorus first. So we got to put a 2 here to balance our phosphorus, and then a 6 here to balance the nickel. So 6, 1, 2. Okay. So 1 mark for Ni3P2 and 1 mark for the balancing being correct. Okay, and then our last one here, we've got zinc hydroxide reacting with potassium. That's a single replacement reaction. Potassium is the metal, so it's going to switch out with zinc. Okay, so that means that potassium will end up with hydroxide and zinc will end up alone. Okay, this is a -1 and this is a +1, so that compound is okay the way it's written. Okay, zinc isn't special, so it's just going to stay like that. And then we've got to balance this thing. So I've got 2 hydroxides over here. So sorry, 1 mark for that. Okay, 2 hydroxides over here. Now I have 2 hydroxides on the product side. I need to put a 2 in front of potassium on the reactant side in order to make it balance. Okay, so their balancing should be 1, 2, 2, 1. Okay, mark out of 10. Okay, let them see it and then put it on the desk here. What else?